So I will present a turnkey solution for industrial IoT. So we work in the IoT world now for many years, and we discovered that for industry we need some special tools. So IoTize is based in France, and what we do above all is we try to link any electronic to a mobile application and also to the cloud. So on our work, there are both two sides, two different sides, and we work on okay. So the first thing is to connect the electronic to the cloud. This is very useful for data logging, for example, also for sending alarms. And at the other side, we manage, we generate mobile applications, so either on Android or iOS or even web app, to monitor, to configure the system. So this is for any electronic device. And we developed some small modules. So we have many different types of small modules. Typically, this one features NFC, BLE, Wi-Fi. And this was good for example, for home appliances or for heating systems. But for industry, we realized that they were not perfect for this use. So what we did, we developed also some small gateways. So on the principle, they are the same. We use exactly the same tools, but they are basically adapted to industrial equipment. So typically to a Modbus network or to a CAN network. And we handle these networks exactly as we do with a simple microcontroller. So typically, this is a small gateway for RS-485, so for a Modbus RTU device. And in that case, we also generate with the same tools mobile application. So it will be useful if you have a local configuration to do. And if you want to monitor from the cloud, or if you want to data log or to send alarms, it will work as well. So what is important for us, it's basically it's a no-code solution. So you adjust to make configuration. And then above all, if you want to send alarms, you have to write a few lines. And in this case, it will be a low-code solution. So typically, when you want to send an alarm, you need to define exactly the context, to specify not only a range of temperature, for example, but for example, a certain time. And yeah, in that case, it's very useful to write a few lines. So for the mobile app, we always feature, we have always NFC. NFC is very useful to launch the app, to install the app first. And if I see here, this is a NFC-only device, but it's for a radiator thermostat. It's not industrial, but it's the same principle. And we launch the application thanks to NFC. And if there is BLE or Wi-Fi, we can do the pairing. So if you have different devices, we choose the right one thanks to NFC. We can also apply the security rules at the NFC level, so the authentication. And we start the encryption at the NFC level. So it means that typically if we have a Wi-Fi device, the Wi-Fi could be sleepy, and we wake it up with NFC, and then we create, for example, a key, and everything is done very closely because NFC works only up to 3-4 centimeters. So for security, it's a very good feature. And it's also energy saving because, as I said, if you just stop the Wi-Fi and it will start only when you need it. And yeah, it will also save radio waves. And so you can communicate with your mobile with any of the classic radio channels, so NFC, but also BLE and Wi-Fi. So for Wi-Fi, you can use either your device as a hotspot, access point device, or in a network, within a network. And now what we added, and the most important added value for us, is the generation of the mobile applications. So we generate automatically mobile apps from the configuration, and then you can, of course, for each value, you can select the graphical representation of a variable, and then you can, if you want to improve it, you can do it. You get the source file, you get a project, and you improve the whole application. So for the cloud, we work with any IoT platform, so it is done by configuration. So you have to add the certificates to specify if there is a password, you have to add the password or a token. And it works with all the popular platforms. And we also have some, for industry, we have some gateways with modem devices for LTE and for NB-IoT. So by this way, you can also send alarms even if there is no Wi-Fi available. So the global features we offer is first user management. So user management means security, authentication, but also you can define different profiles of users. For example, if someone is a technical guide just for configuration, the rights will be limited to configuration. And if there is a user that only may look at the values but not change the configuration, you will define a different profile with different rights. So this is done by configuration, and you can define how many different profiles you need. For the configuration, so that's I would say the main use when you want to communicate with locally with the system. Monitoring means, yeah, you want to control your system, but for example, you have an electric device, you don't want to be connected, you can do it remotely. This is remotely just at a few meters. And then you can use a remote access, so even for data logging alarms, or the app we generate also manage MQTT. So the generated app can also monitor remotely. So the solution is mostly we have a firmware that is the central part of the solution, but around we need some hardware. So typically electronic modules or gateways for industry. So we have different hardware, and I would say the main part of what we offer is the tool suite. So the tool suite is available for free, but for us, for sure, it is the part where we work the more. And of course, we can offer also services. So now we consider we are on two different markets. So OEM we have modules, and gateways for industry. But for both, we share the same firmware. Typically, in this device and in this device, the binary firmware are exactly the same. Only the configuration will change. And we share the tools, so typically the configuration tool, and also we embed a Java virtual machine for the low-code solution. And the same Java tools will be available, of course, for both markets. And when you generate an app, a mobile app, yeah, it will be the same suite of tools, so the same generator, the same configurator, and yeah, no change for that. So typically for industry, we manage at the wire side, different types of wire network. So RS485 for Modbus RTU, or Ethernet for Modbus TCP. Also CAN, so and then USB and RS232. USB is more typically to connect if you have a industrial system that is managed with PC 104, industrial PC. You can connect this gateway to the USB port. In that case, you will have the benefit of the app generator. So you could have a mobile app to manage a system that will not be the main monitor of the PC or the computer. And we have two extensions for these types of tapioca, one for LoRa, so LoRa1, and the other for LTE and NB-IoT. So then after you add typically a SIM card, and you can connect to the networks. And yeah, we added this board because recently we had two customers who wanted both RS485 and Ethernet, and because of that we added a board where we have both our Modbus RTU, Modbus TCP, and the Ethernet can also be a replacement for the Wi-Fi access. Sometimes it is useful. So for the firmware, our firmware is based on the LWM2M, so it's LWM2M is an open source library, and we added many different objects. So one for configuration, one for the firmware update, so we can update our firmware thanks to this, for the profile, for the users, for the data log, so many things. And for the variables. So for the variables, we can read variables either outside, so on the target board, or inside our device. So it means we can have local variables, and these local variables could be addressed either by the Java machine or by, typically, if we work with a Modbus network, we could be also either a master or a slave, or in that case, if we are a slave, we are addressable. So these variables will be addressable from outside. And we added the Java machine. So the Java machine has different purposes. One is to send MQTT message. So we have a JSON class, math class, string class, everything required for building MQTT message to any platform. So it's quite easy with Java to build such a message. And the Java machine has also an access to the LWM2M, so it can read values, it can access variables, read or write, it's always read or write. And okay, the Java machine has also access to special peripherals, but this is available almost for OEM modules, not for industry. So for security, we use an end-to-end process. So the name is CRAM, so it's something public, well-known. And it means we share secrets between the two ends. And over this, typically if you are in a remote session, we add TLS, so TLS for MQTT, known as MQTTS. And but in that case, an additional security will be the security of the broker. If you need a certificate to be connected to the broker, I would say the first level of security will be the connection to the broker. And locally, as I told you before, we added NFC that is useful to do authentication and also the building of the encryption keys in silence. So I mean very closely without being listened externally. So there are many different bricks embedded in the firmware. So it's just a summary of what I explained. So in Sky Blue, the firmware and here what we offer in the tools. So we typically, we can load the tables of variables in different formats. So for CAN, it will be DBC. For Modbus, it will be a CSV, an Excel file. Or yeah, for microcontroller, it will be an ELF file, or etc. So this is a screenshot of the configuration tool. So it's something very easy to configure. You have to define the context. I think it is easy, but it is not always so easy for depending on the people. So for an engineer, it's quite easy. If you are not engineer, it will be difficult. And it's why we develop some new tools that are more adapt to the industrial environment. So we have on the right, it is our debugger for the Java machine. And yeah, screen of the, yeah. So this is present the generator for the mobile apps. So typically we start from the configuration tool and we generate a project. So a project is a set of source files. And then we can build these source files either with Android Studio. So this could be done directly on our server, or if you download the files, you can generate the version for iOS or for typically a web app. And now we have different types of application. It could be one application for one device. So this will be done by an engineer. But then we have a new mode called dynamic mode. In that case, you will have a frame of application and the dashboard will be external. And you could download a new dashboard for a new device or for a new site. And we develop this idea because of the industrial environment, because we work with some companies. They have many different sites. It's always the same, one PLC, many sensors, but there is always some differences. And they don't want to send an engineer for the high-end configuration every time. They want something easy to configure. It's why we work on a multiple dynamic version where it is only needed to configure not the whole information, typically the security, the profiles, you don't have to change them, but only the variables. If you have one sensor, you change the Modbus address of the sensor, you change the name of the sensor, the type of the sensor, you do that and only that. So this was our first original approach, and this on the right, our new approach. And in the new approach, we split the configuration between the variables and the non-variables settings. So for the variables, you can just, typically on a Modbus RTU network, you will just redefine one variable, and this will be quite easy. And this will be used for the mobile app, but also for the cloud. In that case, we define a format for sending the information, so either through LoRa or MQTT, where we specify for each variable the size of the variable, how we can compress it to be sure it's like a CAN bus. We can compress in signals, so it works yeah, in the same idea. So it's after you will send a very compressed set of bytes for the whole data logging you want to send typically. So this information will be sent to the mobile app generator to define a new dashboard, and to the IoT platform to adapt when some data will be received, to adapt the decoding of the data. So we see here the two parts. So the general settings will be configured typically by an engineer. The profile, the security settings, the communication, the Java code. The Java code will be one Java code for all the different sites. And then you will focus only on the variables. So it will be something much easier to modify. And yeah, after this is a screenshot of the server where you can just redefine the variables. So you pick, you drag and drop some variables, you define the new configuration. If you want a jauge, if you want a chart, if you want a bar graph, you specify which one you prefer. And when it is done, you generate the dashboard that will be used by the same mobile application. So it's much easier to just to focus on the variables. And yeah, so for the data packing, so the interest is to have a single Java. So it means you will need to write a few lines of Java for the very first configuration. So we provide some generic Java code for MQTT and for LoRa. But then if you change something, if you modify the set of variables, the Java will not be changed. So that is very important, because it was one, we used to say it's very easy to use, but sometimes it was not so easy. And we went in that way for this reason. So typically, if you have two different sites, you will have the same basic configuration, and you will generate two different configurations for the variables, one for the site 1, one for the site 2. And then when you will have defined also the graphical representation for your different variables, you will have two different dashboards on the same application. And when you will tap one device on site 1, it will be the dashboard of the site 1. And then if you go to the site 2, when you tap your device, you will have the dashboard for the site 2 with different graphical representation. And it will be the same for the cloud. When you will have the configuration will be done, the files dbiot1 and dbiot2 will be sent to the IoT platform, and the IoT platform will be able to decode the data from site 1 and from site 2 that are just different in the contents. The format will be the same, but it will be compressed as much as possible for each site, and but it will be the same code for the Java and for the cloud. So it will be something very, very generic. So for conclusion, so we generate apps to monitor, to configure, also remotely a system. We can adapt the dashboards very easily on the site. Typically, if you change something on you change one sensor, you have not to redefine everything. You just modify the set of variables, and you will get a new dashboard. And after, you can, of course, use this dashboard locally for monitoring, for if you want to change the settings of your system. And at the end, what you have done will be also useful for decoding on the cloud the data that will be sent. So we manage always both sides, the mobile applications and the cloud. So I thank you, and I don't know if there is any question.